data. Okay, so let's understand what exactly is the data. Okay, so everyone will have a different opinion or different viewpoint about the data. So can anybody tell me what do you think the data is all about? So we discussed like it's all about extracting insights from the data. It's all about mining your data. So everywhere, we were talking about data, data, data. Okay, so but what is data?
It's collecting of information in a format that is required for our analysis.
Mm-hmm.
Yeah, it's basically a dump of what all information that we can gather
Mm-hmm.
about a certain aspect that we want to analyze on.
Okay. I consider this as a business definition, but from a data science test point of view, it is a little different. So data, definitely data has information. Okay, so we call data and information as synonyms, but they are not synonyms. Okay, data contains information. Data contains knowledge. So, but it's not a very simple way of extracting the information. You have to do some level of even basic analysis on the data to mine that information from the data. So, in data science language, the whole process starts from raw data. Has anybody heard about this raw data?
Yeah.
What do you mean by raw data?
Basically, collecting whatever data we can do. It is basically in a very, I should not say unstructured. It is any kind of data that we put. It's basically a dump.
Okay, it's a dump. Okay. So can we put it in the way that, okay, if we are capturing any details as is, okay, from the way it is getting generated, if we are capturing that data, can we call that data as a raw data without doing any transformations, without doing any kind of manipulations on the data? If we are considering the data as is, when it from where it is getting generated, that data is called as a raw data. So for example, if the data is, if any machine is spitting any kind of a data, okay, in from sensors, from IoT devices, if we are capturing that data as is, we are calling that data as a raw data. If we are capturing the data from any transactional systems, okay, as is, then it is considered as a raw data. If we are taking videos or images or extracting some data from the websites, the way it is, okay, it is considered as a raw data. So in any organization, there would be three layers of capturing and storing that data. One layer is known as raw layer. Second layer is known as curated layer. Third layer is known as consumption layer. Okay, so all the data will be stored in three different layers. Okay, we call this a three-layered approach. In some of the scenarios, you will find the four-layer approach also. Okay, and together, if we put it as a whole, we call it as a data lake. Okay, so raw layer is where you have different sources, data sources. It could be IoT devices, it could be some applications, it could be few transaction systems. Okay, we directly extract that data from all these data sources and dump it into one single repository. Then that becomes a raw layer. Okay, and from this raw layer, you cannot derive any information. Mhm. Because all this data would be in a very raw format. Okay. all the documents, images, videos, even the structured data. There would be too many variables. The data will be having a lot of discrepancies in the data. So as is, if you use it, if you consume this data, it will not give you any meaningful insights or information. So what will happen is, you might have heard about ETL, extract, transformation, and load. Okay, so that is a very common term, okay, which we use in the data in databases or even the data engineering aspect. So there would be a lot of transformations which you have to do, on the raw data to make it clean and, to make it in a better format on which you can perform the analysis. So we call it as a curated layer. So curation, it's curation is nothing but data cleansing, data normalization, data standardization, and all those things. If you do it, then that is known as curated layer, where the data would be in a very clean format. Now, what you will do is, now on this, you can perform the analysis. Okay, so you can do descriptive analysis, you can do predictive analytics, you can do different kinds of diagnostic analytics on top of it, because the data is clean. So it is not having any kind of discrepancies. So whatever information you derive out of this curated layer will give you a meaningful information. And what you can even do is, you can analyze that, you can aggregate the data, you can bring out some other meaningful insights from that, and again you can capture into one more layer, which is known as consumption layer. And this consumption layer will be used, to integrate with various other downstream applications which the business users will use. It could be a dashboard, it could be a report, or it could be any application from, which will consume the data from this consumption layer. So in these reports, in these applications, you will get all the predictions, all the diagnostic analytics results. You will even also get a lot of KPIs related information and everything, which can be consumed by the business user as is. So if you're seeing in this whole journey, in this whole process, this raw layer is not directly being fed to the end applications. Okay, the end users are not consuming the directly data from the raw layer, because the raw layer will have a lot of data issues, the quality issues, and if they directly use that data, they may not get the right insights. Okay, so as I mentioned multiple times, like it could be the garbage in and garbage out. So if you feed the garbage, okay, so you will get the incorrect predictions, incorrect analysis, incorrect output, okay, and that would be as equivalent as garbage. So there has to be some level of pre-processing, some level of data curation, data cleansing, data normalization, everything needs to be performed. In the data engineering language, we called as a data pipelines. And if anybody is from data engineering background, they can able to relate. Okay, so these guys, data engineering guys, they build various pipelines. So this is one pipeline, for data extraction. We call it as data ingestion. So for data ingestion, there would be a pipeline. For data transformation, there would be a pipeline. For loading, there would be a pipeline. So this is called as ETL, extraction, transformation, and load. For each of these steps, okay, the people, the data engineers need to build a different pipelines. So in any ecosystem, business ecosystem or a landscape, okay, all these pipelines will be built, okay, and it will work automatically in terms of extracting the data periodically from all these sources and dumping that into this particular data lake. Once the data is dumped into this raw layer, these pipelines will get invoked and all the transformations will be applied, okay, on this data, and the new data will go and get added to this curated layer. Once the data is added to this curated layer, again, there would be a different set of pipelines. It could be a machine learning pipelines. It could be a descriptive analysis pipelines. It could be some other pipelines, which will bring out some meaningful insights. And again, it will dump that into this particular consumption layer. Once the data is dumped into this consumption layer, the end users can able to utilize that particular data, for their decision-making process. So this is the overall process. So when we call data, okay, so data could be a structured data, could be an unstructured data. So can anybody tell me what do you think, is a structured data and unstructured data? Anybody? And there would be one more, which is known as semi-structured data. Okay. So these are different data types, okay, which we come across when we are dealing with the data. So we'll understand about all these three different types in few minutes. But before that, when I'm saying it's a raw layer, okay, where we will dump all the raw data. So here the data is nothing but, which we have already discussed in the previous classes. These are nothing but the events. So when any transaction is happening, that is considered as an event. And this data, which is sitting in the raw layer, is called as historical data. Historical data means it's the past data. And we can call it as these are all past events which have occurred in the past. Okay, so if any transaction has happened, so that is a past event. Okay, and that data, all the details related to those transactions will go and sit in the raw layer. So if it is your transaction systems, as soon as the transaction happens, so that will become a past event, and that event that data will go and sit in this raw layer. And when it sits in the raw layer, there could be certain discrepancies. For example, in that transaction, the city or where it has happened, the location column may go blank because of manual process issues, or because of some system issues, or it could be any reasons. In this raw data, certain values may be missed out, okay, while capturing. So when we are curating, we have to go and check, is there any kind of a missing values in the data? Okay, sometimes the data can be captured incorrectly. So for example, instead of 100, it has captured it as 1,000. It could be because of typos, it could be because of the system error, or whatever it may be. So again, we have to go and validate, is this value correct or is this value wrong? Okay. So there are certain techniques, okay, through which we can able to identify these kind of anomalies in the data. Again, we have to go and correct it. Okay, because if you don't correct it, it will take it as a genuine value, and the calculations will, while you are making the calculation or while you are making the analysis, it will consider instead of 100 as 1,000. And right, if you take 1,000 instead of 100, then obviously, whatever calculation you will do, will give you a incorrect results. So in short, the data is nothing but the collection of events, and these are all past events. And all these past events together is called as historical data. And as a data scientist, our job is, to use this historical data, to mine this historical data to bring out insights to these end users, okay, who are consuming this data. Now, this is a whole process we need to understand in detail. How the data is changing its shape, how is data is being transformed, and how the data is being analyzed, and how, in the end, the end users are consuming that data. Okay. Now, when we talk about the data, okay, as I mentioned, there are three different types of data. One is structured data, semi-structured, and unstructured data. I think I have a slide on that, so we'll come on these slides later. So let's first understand the structured data. Everyone, has dealt with structured data in some way or the other. So this is the data which is in the form, which is in the form of some structure, okay? There is some structure around it. So for example, the tables. the Excel sheet or the databases like SQL, Oracle, okay, all these kind of databases, relational databases will capture the data in some structured format. When we are saying structured format, that would be captured in the form of rows and columns. So the column headers will give you the information about certain attributes. So for example, if I'm capturing the customer data, so the first name, the last name, age, income, gender, okay, all these are the attributes of this customer. And these rows would be the customer, unique customer details. So we can call it as, and we can differentiate all these observation by customer IDs. Okay. So for example, this customer ID, if you talk about that person's first name is this, last name is this, age is this, income is this, gender is this, is properly in a structured format. Okay, I can able to understand this data through this structured data, through this structure easily. Okay, I can able to count how many customers are there. I can able to find out, okay, how many customers are there in a particular age group. I can able to see, how many customers are falling in this particular income group, in this particular gender group. Okay, all that thing is can be easily analyzed through this structured data. And we use this structured data only most of the time, right? And when we talk about data, okay, we always feel that this is only uh, a format for the data, which is in the form of rows and columns. But it was there earlier. People were using only structured data for the analysis, where they will have a labels like vendor ID is this, vendor name is this, currency is this. This is an application. Okay, if you have an application like this, from this application you can extract the data in the form of table, because you have labels here and you have the values here. Okay, so if this is the vendor ID, this is the value. MS will be here. Vendor name, Microsoft Corporation will be here. Okay, currency ID, if it is a column, then this is that. So for this particular event, okay, these are the details. It will get captured. Now somebody else has entered one more transaction here. So all those details will be captured in this format. Okay, so like this, it will keep on updating, okay, this whole table. Okay, and that data will be called as a structured data. Now here the attributes are properly labeled and distinctly visible. Now from here you can easily able to identify what is the label, and if you want to extract information for a particular event or for a particular transaction or for a particular customer, you can easily able to extract that information, or you can easily able to query that information from this particular data. So it is easily searchable and queryable. Okay, you can just write one single query saying that, okay, pull out all those customers uh, whose age is less than 35 years. You can easily pull out all that information from this kind of data, and it can be stored easily in the tables. Okay, so if it has proper labels and the values, it can be easily extracted in the form of table. So if you encounter any such kind of data, then you can categorize that data as a structured data, and it is very easy, to analyze this kind of data. Okay, and there are multiple databases which are there, okay, in the market, to store or to capture this kind of data. But now there is a whole different field, okay, I'll say area, which of unstructured data. Now, when we are saying unstructured data, it's the data which cannot be stored in the form of table. For example, text, for example, images, for example, videos, audio. Even this is data. And the definition of data is nothing but a data which contains information and the knowledge. Don't you think even the text contains information? Yes, even the text contains information, right? If I give you this kind of paragraph, okay, it also contains information. But how can you extract? Here, querying is difficult. Here, if you want to search for certain information, is difficult through some programmatic way or through some scientific way. It is difficult. You can just only read, and through your human intelligence, only you can able to extract the information. Okay, but in the structured data, you can run queries and you can derive the information. But for dealing with this kind of data, it's not trivial. It is difficult. It is challenging because it is not that easy, to analyze. So now you would be surprised by knowing that almost 60% of the organization data, more than 60% of the organization data are unstructured, is unstructured, and they are facing a lot of issues in terms of um, extracting the meaningful insights from that unstructured data. That's the reason they rely on data science and AI, to bring out that information. So I'll give you an example. So if you go on Amazon or any other e-commerce website, people give lot of feedback or reviews, okay, on the product and services, right? Now, it is very important for the business to analyze all that feedback and review, to understand or to get the information related to the customer sentiment, okay, how the customer is perceiving their product or perceiving their services. And based on that, they can take decisions. Okay, they can either improve it, or if they are doing good, they can follow the same best practices in terms of uh, in terms of the product quality and all. So that becomes very key. But how to analyze? How to, first of all, how to store this data? We cannot store that into rows and columns kind of a structure. Okay, because in some of the text it could be one single line. In some of the text, people might give feedback in 10 lines or maybe 20 lines. Okay, it is not a fixed size. Okay, it's not a fixed length. Okay, of those values. So so for storage, it is difficult. Okay, definitely querying is not possible if you store this data into structured databases or relational databases. So you need to have some different kinds of database, which we call as NoSQL database. NoSQL means not only SQL. So these are the database which can in fact store the structured data also and even the unstructured data. That's the reason it is called as not only SQL. It is not, this no means not, okay. It is not only. It is a acronym, okay. So abbreviation is not only SQL. So now people uses this NoSQL databases, like we have MongoDB, we have Cassandra, we have many different kinds of NoSQL databases, which can store the data in the form of documents, also in the form of structured tables and all those things. So here in this example, if you see, it is a continuous text. So here, let's suppose you want to retrieve the information from this text about, okay, which car they are, which vehicle they are talking about, what is that vehicle type, okay, what is the attributes of that vehicle, okay, like, 6-speed transmission, manual or automatic, 2 4-cylinder engines. So in this particular paragraph, there is some description about this particular vehicle, and there's certain information related to that particular vehicle. So these, all the orange ones, are the highlighted ones which the business would like to extract from this particular data, okay, which would be information for them. So here the problem is these attributes are not distinctly labeled. Okay, in some of the paragraphs, these information could be in the end of the paragraph. In some of the text, okay, it could be somewhere in the middle of the text. So there is not a fixed location of that information which you can extract. So the attributes are not properly distinctly labeled, and they are not present at one single location. Okay, so to extract that information which is present within this data is kind of challenging. It's not easy. So querying is not easy. So now similarly for images, okay, in the images, let's suppose you have an image. Okay, you have a, let's suppose, factory uh, image, okay, in which you will have certain people, who are working on certain machines, okay. There will be some other machineries, okay, nearby. There will be different people walking around and all those things. There is an image. Now, out of that image, you want to find out the information, right? How many people are following safety protocols? Okay, how many people are wearing mask or helmets or safety gears like jackets, boots, gloves, and all? So how can you extract that information? Or you want to count the number of people, okay, in that particular factory, okay? All that things could be done only through manually, okay? Just like this, okay? If you want to extract these information, you have to manually read this text. Only the humans which have the intelligence can able to mine through this unstructured data and can bring out the information. That was the kind of situation we were in, earlier. So definitely, the flow of this unstructured data would be high because there are so many applications, so many sources from through which you can source all this unstructured data. But the processing is not easy, and if you are putting people or or the manual process to extract that information is going to take a lot of time. So generally, from that scenario, we have reached to current era where you can use certain techniques to process or to mine through this unstructured data. When you are processing this text data, we call it as NLP, natural language processing. So we have certain algorithms, we have certain techniques and methods, which people have discovered through which we can extract or which through which we can extract the meaningful information and we can parse through this textual data. Now through this NLP, I'm just giving you an example. You can extract sentences. In from the sentences, you can extract part of speech like what are nouns, what are verbs, what are pronouns, and all those things. Okay, different part of speech you can extract. And the same way, after extracting that part of speech, you can put it together, to train certain models also. So for example, now I have different feedback. Certain feedback could be positive, certain feedback could be negative. Okay. In positive feedback, I will train the model in such a way that it will understand in a positive feedback what kind of words are used. For example, happy, uh, for example, brilliant, excellent. All these are positive words. There's a high chance that they will fall in this positive comments. In the negative comments, it could be sad, it could be frustrating. All these kind of negative words could be part of negative comments. So the model, firstly, we will do some pre-processing to extract those keywords from the text, and then we'll put that into a model to understand what kind of words generally being used in the positive comments and the negative comments. And the model will become intelligent enough to decide on its own that which comment is positive and which comment is negative. So that is called as sentiment analysis. So that is one of the use cases I'm talking about, but there are plenty more different kinds of use cases which you can perform on the text data. Now coming to images, we use here computer vision, or we also call sometimes machine vision. So what this computer vision will do is, again, there are different set of algorithms and processing techniques for image processing, okay, which you can apply on this data to, to, for here you are extracting the keywords. Here in this images, you can extract certain patterns out of these images. Okay. Once that pattern is extracted, now you can use certain algorithms, to detect the objects. So for example, person. Okay, so I kind of trained a model which can detect person or the faces out of the image. Okay, so you are using in your mobile phones. When you switch on your camera, okay, you will see a box around the faces, right? When you take the picture. So there is a face recognition algorithm which is running behind the scenes. You can further train the model on top of it, which can automatically even detect the name of the person. Okay, so it will recognize through image processing, and after that, once the face is detected, okay, or recognized, then you can label that face, by a person name. So you have to train the model in such a way that you have to put the faces along with the name, and the model will able to understand, okay, who is this person. So for example, now there are certain models which are pre-built models which are there on the cloud, or which are there on certain applications, which can detect the celebrities' faces. They have trained on those faces. And even in certain organizations, there are certain solutions which are running internally, which can detect the employees, okay, by their faces. So identifying the face, identifying the objects, okay, and then lot more you can do it on this. For example, object detection, object recognition, object tracking, and based on that detection, you can further improvise on top of it, to build some intelligent system which can take certain actions based on that analysis. For example, if your face has been recognized and you have been identified as an employee, then automatically the gates will open, okay, and you can enter into the office premises. Okay, so you can build such kind of intelligent applications on top of it. So coming back, so we have seen there is a structured data, there is an unstructured data. So basically the text, images, audios, and all these things are considered as a unstructured data. Now, in data science, you might have, uh, by now you might have understood that this is a discipline which contains the usage of mathematics and statistics. And this mathematics and in statistics, they're all you will find all numerical operations being happening in the statistics and the mathematics. It will all number games, right? So data science is all about numbers. Okay. Now, when we talk about the text and images, where are the numbers? There's no numbers here, right? This is the text. Okay. These are alphabets. Okay. In images, again, there's no number. So there is a process through which, we convert this unstructured data like text or images into numerical data that we will understand, okay, when we get into NLP and computer vision, how we do that. And we can even do some statistical analysis and even mathematical methods or algorithms we can apply on this unstructured data also after converting this text and images into a numerical form. Okay. So by now you might have understood that dealing with unstructured data is much more complex and much more complicated when dealing with structured data. Okay, and that's how this whole field of dealing with unstructured data has become very, very important. And these skills are something considered as a niche skills because it's not that easy. And to learn this field, it's so you have to understand a lot of other things. Okay. So we'll discuss more about that later. Now, in between this structured and unstructured data, there is a semi-structured data also. In some of the cases, the data which is coming from the applications, from the sources, it will have both different kinds of data. It will have a combination of structured as well as unstructured. For example, email. Email, let's suppose I'm capturing all the emails. For example, Gmail, okay, people are using. So Google is capturing a lot of semi-structured data and they are doing a lot of analysis on that data. In this semi-structured data, there would be certain data which is easily queryable. So for example, in the emails, from the emails, I want to capture the data like emails coming out from this particular person, like Ram. Okay, so how many emails I have, from this particular Ram. So that is easily queryable because in the email, I have a label like from, okay, where I will have the information of a sender, okay, who has sent that particular email. There would be to, there would be subject, there would be date, and all those things can be easily queryable. These are all structured data. Now, when we talk about this body text, which is the email content, it is more of a text. People may write different things, in the body text, right? So it is a completely unstructured data. It will be sitting in one particular block, and to analyze and to mine that information from this particular content would be difficult, and we have to deal this data as an unstructured data. And in this unstructured data, again, this particular table is a completely structured data. To mine this information, it's easy. I can just pull this particular block and paste it in the table, and I can able to query that information. But querying this information or processing this information would be a challenge. So here I have to deal with NLP. Okay. So even there is another example like log data. Behind every application, there would be logs which will be getting generated. So now I'm using this Zoom, right? So inside this Zoom, also the logs are getting captured, okay, getting collected. So log will have different information like, what is the CPU usage, what kind of memory it is using. Okay, all that information, will be collected on a real time. At every timestamp, that will collect. Okay, when you are running your system, okay, so in the back end, there would be logs which would be getting collected. And in that log, there would be some kind of unstructured data also. Okay, so for example, let's suppose if some error has occurred. Okay, so there would be error description. Okay, so that error will be captured in the logs. So that will be treated as an unstructured data. So there would be structured information and there would be unstructured information. So when you are dealing with both in a single data, then that becomes your semi-structured data. It is a mix of structured and unstructured. So in this semi-structured data, some attributes are distinctly labeled, as I mentioned, from to, so because in every email you will have these labels available. So capturing this information and extracting this information, from the data, it's easy. But extracting this information from the body text would be difficult. So other informations would be hidden within this free text. So again, in this kind of scenario, firstly, what we do is we identify the structured data and the unstructured data, and this is completely a data engineering job. Okay, so here nothing, data science will not play any role here for distinguishing the structured data and the unstructured data. Once the structured data and unstructured data has been segregated and been properly stored, then we use data science to extract the information and the knowledge from that data. Okay. So by now you might have understood what is data, right? In and all, how this whole data ecosystem works and what different types of data. Now, these are types of data. Okay, different formats of data. Okay, structured or semi-structured or unstructured. Now, you might have heard about big data now. So what do you mean by big data? Anybody? Have you heard about big data? People talk about big data analytics, big data, and all those things, right?
Srikanth,
Somewhere. Yeah.
large or huge amount of data.
So this is very generic. Okay, this is something, how you can call any data as a large data. This is
When
something,
your
after
data,
a particular value, after a particular size, the data is considered as a large.
like terabytes or petabytes.
So below terabytes, it is not considered as a big data, or below petabytes. So definitely, whatever you're saying, terabytes and petabytes, these are large scale data. But when we are saying, so when the transition happens, like from data to big data, so is there any particular threshold at which we can say that, okay, if it crosses 15 GB or 125 GB, then only it will be called as big data? Is there any rule? So it is a very generic way of explaining this particular term big data. People just say that the data which is huge is considered as a big data. But what is the definition of that huge? Is there any size defined that beyond that size, the data is considered as a huge? and data is considered as a big data. Definitely petabytes, terabytes are huge for us. But do you think for Google terabyte data is a big data for them? For them, it is a very tiny data because they are dealing with zettabytes of data. Okay, so for them and millions of terabytes of data in a day, in a second, they process. So for them, 1 terabyte is not a big deal. For them, it would be just like a megabytes for us. So understand that, okay, for every organization, the definition of big data varies. And I would like to tell, we we define big data only by volume, but it is not just volume. So there are four V's by which we define big data. One is of course volume, which you have mentioned. Now let's discuss about volume. Okay. For example, your laptop can hold 20 GB of data. Let's suppose your hard disk size is 20 GB data, 20 GB, and your RAM is, let's suppose, 6 GB RAM. Okay. So for you, if I give 30 GB of data, can you able to process in your laptop? You have only 20
No.
GB storage. You cannot hold 30 GB. Now, would it be a big data problem for me? Will you not say that data is huge
For me.
for you, right? Let's
Yeah.
suppose there's another person who is using 1 terabyte storage, okay, 40 GB RAM. For them, processing 30 GB would be a problem.
No.
No. And they will not say that my data is huge and they will process this nicely. So this is an example for organization also like this, okay? Whatever infrastructure they have, based on that, they can define whether it is a big data problem or not. Certain organization who is having a small data centers, okay, and they have a small infrastructure, for them processing data which are in some terabytes, okay, would be a difficult affair. Okay, for them, it's a big data problem, and they will look out for certain tools and platforms which can process that much amount of data. So when we are dealing with volume, so there are certain tools and platforms available which are based on Hadoop. Okay, you might have heard about Hadoop. Okay, so Hadoop is a big data tool which can process the data parallelly. So what you can do is, as you are using a low-end computers, okay, low-end computer, what you can do is you can purchase one more computer with the same specification. Like you are having a 20 GB hard disk and let's suppose 15 GB RAM or 12 GB RAM. You will add one more system to your system. Then you will have two systems. When I'm giving you 30 GB data, what you can do is you can distribute the data into these two systems and you can process it parallelly. So we call it as a parallel processing or a distributed computing, which Hadoop can do that. What it does is Hadoop is not a one single technology. When you look at Hadoop architecture, it is a whole ecosystem. There are multiple other sub tools and sub technologies which are there in this entire Hadoop architecture. What it does is one particular tool, what it does is it will divide the data into chunks, into small portions. We call as a data partitioning. So the data will get partitioned and it will moved into different nodes. So different systems, what I'm talking about, consider as a different nodes. One would be a master node, another would be a worker node. So don't worry about this. This is all a data engineering jargons. Okay, I'm just explaining you how this whole process works. So data will be partitioned. All the instructions will be taken by the master node, and the master node will feed the data and will give the instruction to the worker node to process. So let's suppose there is a one master node, one system, and along with that, there are 3, 4 systems which are connected. So as a user, you will give the instruction to the master node, and the master node will pass that instruction to the workers node. Okay, and the data will be splitted, the data will be partitioned, and that will process parallelly, and all the results of those nodes, worker nodes, will again aggregated and will be reflected on your master node. So this is a kind of a high level architecture, we call as a parallel processing or distributed processing. And this whole connection of master node and the worker node is called as clusters. These clusters you can create in your own data center, in your on-premise data centers, or else you can create these clusters, over the cloud. On the cloud, it is easier because there you can choose the VMs, okay, virtual machines. You can use this, you can select the servers, what servers you want to use. Either you can go ahead with one high-end server with 1 TB RAM and all, 1 PB storage and all those things kind of, you can scale it to that level. You can just take one node and you can process everything there. But what will happen is you have to consider one dedicated machine, and for that pricing will be very high. So what usually the typical businesses they do is they take the low end machines and they create a cluster. And even in this cluster, you need not to have a dedicated clusters. Only the master node should be dedicated. The worker node will be picked up based on the data size. If the data size is 30 GB, then it will pick up only one worker node, and you have to pay for only one worker node. If the data size increases to 10 TB, then appropriately that many number of nodes will be picked up. Okay, automatically it will spin up. Okay, those many machines and your cluster will be scaled up, and you can process that much of amount of data. Once the data processing is over, the virtual machines will automatically get shut down over the cloud, and again you need not to pay for those machines. So this whole concept on the cloud is known as pay as you go. How much you will use, that much you will pay. So that's the best part. That's the advantage why most of the businesses they are moving towards cloud when they are facing a big data problem. And as I mentioned, every business, every company will have a different way of defining the data as a big or huge. Okay, that's a volume. That's the first V. Second major problem is velocity. Now, when we are talking about IoT, when we are talking about sensors, when we are talking about websites, so data is getting generated on a real time. Every fraction of seconds, every fraction of minutes, the data is getting generated. Now, again, major problem what businesses are facing is, to process that data on a real time. So it's not something like I'm getting the data from the sensors, which has been mounted on the machines, which is on the real time capturing the temperature, pressure, voltage of that machine, and I am analyzing that data, after 1 hour or after 2 hours. What will happen in the meantime? Okay, the machine will fail, all the damage will happen, and your whole plant will shut down. Okay, all the uh, losses you have to incur. So the only way out is as soon as the data is getting generated, I have to process it. If there is any kind of abnormality in my machine is being captured, then I have to process it and I have to identify what is that problem. Okay, and I have to take the immediate action to avoid that kind of loss. But for to do that, I have to do a real time processing. And even on the website, if the person is on the website, if you don't provide the recommendation in that moment, then it's of no use, right? After an hour or after 2 hours, if you go and show the recommendation, either that person will be moved out of your website, or else he will be not be interested to buy, or else he might be in the verge of completing his transaction. Okay, so again, the time is very very important, very critical in both the scenarios. And in those scenarios, the real time processing is the only way out. And when you're doing real-time processing, sometimes the data would be too huge to process. So for example, on my website, at a particular minute, at least there are 300 to 400 people who would be logged in. So the traffic on my website is pretty high. Okay. So in that case, it's not about one person's data I have to mine hundred and millions of people's data in that particular second or in that particular minute. So it is volume plus velocity both is my challenge. Again, for that, there are certain tools and applications which are there. Okay. So On top of Hadoop, once the big data problem, volume problem has been resolved, then people started getting this velocity problem. So what this same company, okay, it's the same, so it is Apache company, Apache Hadoop, we call. So this Apache is the open, it's a kind of a non-profit organization. Okay, so they are technically they develop the applications and they give it as an open source without any cost for people, to use it. So all these other vendors like cloud vendors like AWS, Microsoft, and all those things, and other platforms, there are many other proprietary platforms. They have used this open source framework, and they develop their own product on top of it. Either you can use as is to solve your problem, or else you can use some other proprietary tools which have been developed on top of it, to address your needs. The same community, they have come up with one more tool known as Spark, and there is one more product known as Storm. So Storm is kind of become obsolete, but the Spark has gained momentum, and it has become a popular tool for real-time analytics. Now, the Spark is being designed on top of Hadoop. Now, what this Spark does is it does a near real-time analytics. Okay, it's not exactly at the moment when the data is got generated immediately in that fraction of seconds it will process. It will take a little bit of time. Okay, but not too high time. It will take like 10 seconds or 5 seconds based on again the cluster size. It can do the parallel processing. It can do the distributed computing, and you can do a lot of analytics by using this Spark. So you can train models, you can do predictive analytics, you can do diagnostic analytics, whatever you want. Okay, you can do it on Spark. So that's the reason, we are also covering Spark into this course to understand how to handle this data, which is of high volume and high velocity. Now that is your second week. Now third week comes the variety. We talked about unstructured data, right? So it has again become a big challenge for the people, to mine through a lot of unstructured data. Again, unstructured data would be of high volume, would be of high velocity in some cases, and the variety of the data being collected. The data can flow in the form of PDF documents, Word documents, or it could be simple text files, or it could be extracted from the various websites, or it could be images, it could be videos. So this is all variety of data. So to create a pipelines, or to process that data and to mine that data, even to analyze that data, again a difficult challenge. So there are certain techniques, okay, through which we can use, to tackle with this variety problem. Okay, so there are certain packages available through which you can read PDF files, text files, okay, CSV files, and then there are certain techniques to process those files like images, videos, text, and there are certain algorithms which are there, which you can use, to train models, to build some kind of intelligent models on top of that. And the fourth problem, which is quite common across veracity problem. Veracity means the data quality. When we're talking about data, volume, velocity, variety, and all those things, we are capturing so much of data at a real time, of different formats, different types. There is a high chance of capturing a lot of noise in the data. So that is known as veracity. Veracity is nothing but the noise. So as I mentioned, the data quality should be good, before analyzing. You cannot directly dump the data and directly start. So we have seen, right? Curation is very important. So curation becomes a challenging affair if you are dealing with huge volume of data, and also the data which is live, which is in movement. Okay, to to create and to cleanse that data. When it comes to unstructured data, again, it becomes challenging, to maintain the quality of the data. Let's suppose you are managing thousands and millions of images. In thousands or millions of images, just imagine what would be the chance that all the images would be of high quality. There's a very less chance, right? There would be certain images which would be blurred, which would be not clearly visible. Okay, there would be certain videos where the audios would not be good. There are certain text, okay, in which the format would not be right. Okay, so lot of junk and noise will be also we will capture, okay, while collecting all that data. So again, it is becomes a challenging affair, to deal with that noise, okay, when you are dealing with huge amount of data, with variety of data, and at a higher velocity. So these are the four V's which qualify a data as a big data. Okay, it could be either of these or all of these, okay, but not just volume. Okay. Volume is the key component. It started with volume, but later on, a lot of other things also got added, and the scope of this big data analytics expanded to all these four V's. So when you're talking about big data analytics, it's all about dealing with volume, velocity, variety, and veracity. And there's one more fifth V they have added, which is known as value, which you can ignore. Okay, so value is all about, whether your data is valuable or not. That has also become a challenge. Okay, what value you can extract. Okay, whether it is strategic or whether it is non-strategic. Okay, so again, you can further classify your data based on the value. So that is like fifth V which people have added. But generally, these are the four V's and the four challenges with any data professional has to face, okay, while dealing with the data, whether it be a data engineer or whether it is a database guy or whether he is a analyst or data scientist. Okay, any questions, guys? I hope you got a pretty good understanding about data.
Yes, sir.
Just something, let's discuss this tomorrow. Okay, so I'll wrap up here only. So we understood about the data and all those things. Now tomorrow's class will understand some attributes of data. Okay, that is also important. And why this is important is it's not just simply you take the data and just put that into algorithm and algorithm will spit out some meaningful insights. It's not. You have to understand a lot of things. Okay, and currently you have seen the whole landscape of data, like how wide this data is. That's where these data engineers with different kind of skill sets, understanding of databases, whether it is SQL or NoSQL, uh, understanding of big data tools like Hadoop, Spark, and all those things play a very important role in terms of qualifying themselves as a proficient data engineers, right? So now, from a data scientist perspective, even we need to have a proper skills to analyze the structured data and unstructured data. Even we need to have to build a skills, to extract the insights from a huge data, which is of high volume, and the data which is in movement, like real time or live data or streaming data, or when data is having, when you are collecting data with different formats, how to extract information from that and how to deal with the noise to make to improve the quality of the data so that the analytics can be done properly on that. So all that together, data skills will be also required for data scientists. So data engineers will mostly they will deal with the whole infrastructure, like how to basically on the data governance side. So they will develop pipelines to flow the data from data sources uh, to us to a repository, and then they will be responsible on building pipelines for data curation, and then setting up the whole infrastructure and repository for curated layer and then for consumption layer, and then how to source that data to the applications, again building pipelines for that. So a lot of authorization authentication will come into play, so they have to deal with that. So they have to deal with infrastructure. It has to be scalable. Data should not lose the security, the even the data quality, data governance, metadata management. A lot of things will come like database setup, database management. Okay, all that thing will be part of data engineering team. Okay. Now data engineers, they will have a good understanding about that entire data landscape of the organizational landscape, data landscape, where the data is coming from, where it is sitting, what kind of transformations we are applying, at what frequency the data is getting refreshed and loaded, everything. Now we have to work with data engineers because they have the understanding about this all pipelines, how the data is flowing. So we will work in tandem with data engineers to get the right data, okay, for our analysis. And even after analysis, we give the results back to data engineers to again build pipelines so that the end users can able to utilize or consume that data. So this is a whole big ecosystem in which we work, okay? And not only data engineers, even there are multiple other people, teams will also come into picture like DevOps team, okay? What they will do, they will automate this entire process. They will build CI/CD pipelines, which is continuous integration and continuous development or deployment. So whatever pipelines we have developed. Okay, so as I mentioned, as the new data got generated, immediately the pipeline should trigger, and they should uh, load the data, transform the data, extract the data, and all those things should happen. So a lot of CI/CD pipelines, DevOps, security, everything needs to be aligned to all these different processes. So this whole orchestration of the pipelines and even automation of these pipelines are dealt by DevOps. So there will be some overlap. Now this is whole a big ecosystem. Like for example, in the family, it's not just mother's role, to cook the food, right? Cook the food, or it's not father's responsibility to go and earn the money. So now there is little bit of overlap. Now men are cooking, women are going and by earning money, right? So even the kids have started cooking and all those things. So here also in this whole ecosystem, people are taking additional responsibility also. Sometimes you see that data scientists, they are getting into data engineering role and they are also doing some data engineering work. Data engineers are also moving into data science and they are doing some level of data science. DevOps work, sometimes data scientists themselves they are doing. So in this whole ecosystem, people are doing cross skilling. Okay, cross skilling is happening. Okay, cross pollination is happening. People are picking up the new skills and they are adding it to their profile. And that's the reason if you go and look out for job description outside, even the expectations are also increasing, okay, from the organization. Because all these things are mandatory steps and mandatory process, to build a solution. You cannot skip data engineering and you cannot just concentrate on data science or anything else, right? So it has to be done together. So small organization who can't afford, to have a big team of data engineering, data science, and DevOps, they may expect one or two people who are skilled enough, in doing all these basic things. Okay, they should be known, they should have a skill of data science, also data engineering, also DevOps also, and they are ready to pay more because instead of hiring four people in each of the team, if they have 2 3 people who can do all the work, okay, so they don't mind giving them the high salaries. So don't get surprised when you look at into the job description, when you also see that some of the data engineering skills also people are asking. And as I mentioned, when you look into the job description, if you are qualified with 60% skills or 70% skills, go ahead and apply for those job. Because even if I see from hiring perspective, so when we build a JD, we put everything. And we even ourselves, we know it is highly impossible, to get all the skills in even in one person, one single person. So we always look out for more. And if we get a person with 60%, 70% skills, we are ready, to take them. Okay. So that's what I wanted to discuss in today's class. And tomorrow's class we will discuss about some of the data attributes, like what is entity, what is characteristics, what is environment, what is data set, event, and all those things. And we will take few examples to understand all those attributes. So after tomorrow's class, you will get a pretty good picture about what data is all about. And then from there, we will get into Python programming. So from Wednesday or from Thursday, okay, we will get into Python. So in Python, you will start from the basics. We will understand that whole environment. What is that whole programming language? Why it is popular? Okay, what all can be done through Python programming? And from basic program like Hello World program, we will start understanding every bit of Python with respect to data science. Again, I'm saying we will understand Python with respect to data science because Python is a versatile tool. A lot of other things can be done through Python, but we will stick to data science only. Okay. So with that, I will stop. Let me know if you have any questions, guys. Are we good? Yeah, go ahead. Okay. Okay, we are good. All right. Okay, so if you guys are good, then thank you. Have a nice day. Bye-bye.
Thank you, Srikanth. Yeah.